Okay, this question asks us to answer the word problem. We must define the variables, set up the equations, solve the equations, and state the solution in words. So let's first try to define the variables we're interested in. Reading this, it says, in a recent election, the results from a certain precinct were as follows. 360 votes were collected. The total number of registered Republican and Democratic voters was 5 times the number of independent voters. Also, 3 times as many Democrats voted as independents. Find the number of registered Republicans, Democrats, and independents who voted. So we're looking for how many people from each group are represented. So I've got to define X, Y, and Z to define our variables. So let X be let X represent the number of Republican voters. Y will be the number of Democratic voters. And we'll let Z represent the number of independent voters. So we have successfully defined the variables. That's what we're trying to solve. The next goal is to determine the equations. So let's look at the question again. And it says, the total number of registered Republicans and Democratic voters is 5 times the number of independent voters. That'll be one equation. 3 times as many Democrats voted as independents. That'll be another. But 360 votes were collected total. 360 votes were collected total. We assume that all we have are Republicans, Democrats, and independents in this precinct. So if that's the case, if there's 360 votes total, we know that X plus Y plus Z is going to have to equal 360. Total number of votes is 360. We're assuming they come from these 3 parties, and that's our result. What's the next thing that we're looking for? The total number of registered Republican and Democratic voters. So total number of Republican and Democrats, what would that be? Well, Republicans are X, Democrats are Y. So the total of Republican and Democrats would be X plus Y. So the total number of Republican and Democrats was 5 times the number of independent voters. So X plus Y would be 5Z. And then we need to have a third equation if we're going to be able to solve this. It says 3 times as many Democrats voted as independents. Now, this is a type of sentence that often confuses students. Is the number of independents 3 times the number of Democrats, or is the number of Democrats 3 times the number of independents? That's what you have to think about. What does this say? What does this mean? 3 times as many Democrats voted as independents. And the way to think about this is there are more Democrats. There are more Democrats, and it's 3 times as many. So if there's more Democrats, the smaller number is independents, the larger number is Democrats. So Democrats is Y, independents is Z. There's more Democrats. The Y number has got to be bigger than Z, the number of independents, by a factor of 3. So again, 3 times the larger number equals a smaller number, or the larger number is 3 times the smaller number. This is what we need. Okay, so at this point, we are ready to try to solve this. Can we do it? And we're going to do it with various substitution schemes. But again, notice we've defined the variables, we've established the equations. And again, there's many ways we can solve this. I'm just going to go ahead and use a substitution scheme, recognizing right away that X plus Y is 5Z. So I can replace this x plus y with 5z. So I get 5z plus z is 360. 6z is 360. Dividing by 6, z is 60. Okay. Then we come over here, y is 3 times z. Y is 3 times z. So y equals 3 times 60. So y equals 180. And then we finish here with x plus y equals 5 times z. X plus y, what is y? 180. Equals 5 times z equals 5 times what? Equals 5 times z. What is z? Z is 60. So with various creativity, I can go ahead and solve it to say x plus 80, x plus 180. 5 times 60 is 300. Subtract 180. And we get x is 120. But remember, we wanted to define the variables, we've done that. We wanted to define the equations, we've done that. We wanted to solve the equations, we've done that. Then we have to go ahead and express our solutions in words. So x is 120, 120 is number of Republican voters. So we conclude by saying there were 120 registered Republican voters. Y is Democratic voters, 180 registered Democratic voters. And we will say Z is 60 and 60 independent voters, who are probably not registered as independents, but might be, depending on the rules in your region. So that's how I solve that using substitution. Let's look at another way we could have solved this, maybe using matrix inverses. So I want to rethink these equations and writing it in matrix form to see how we can solve for x, y, and z. Okay, so our first equation was x plus y plus z equals 360. Our second equation was x plus y equals 5z. And our third equation was y equals 3z. So I want to write this in a form that I can use in the matrix approach, which requires x, y, and z all to be on the same side. So if I subtract 5z from both sides here, subtract 5z, subtract 5z, I have x plus y minus 5z equals 0. So I have 1x plus 1y minus 5z equals 0. That's the form I needed to be in for my matrix. Subtract 3z from both sides here. Subtract 3z, subtract 3z. And I get y minus 3z equals 0, which is pretty good. But I'm going to add one more thing to that. I'm going to say 0x plus y minus 3z is 0. So there are my three equations. I'm going to write them vertically so I can easily convert that to a matrix. X plus y plus z equals 360. X plus y minus 5z equals 0, and 0x plus y minus 3z equals 0. So I want to write it in the form ax equals b. A is the coefficient matrix. 1, 1, 1. 1, 1, negative 5. 0, 1, remember that's 1y, 0, 1, negative 3. The matrix X is just x, y, z, little x, little y, little z. And B is 360, 0, 0. So looking at this then, we can recognize that X will equal A inverse B. X is, again, the matrix XYZ. And we're going to get the inverse of this matrix times that matrix. So we will, of course, do that with the graphing calculator. So let's go to the graphing calculator. I will put matrix A in. So second matrix, edit matrix A. And it is 3 by 3. Make that a 3 by 3. First row is 1, 1, 1, 1, enter, 1, enter, 1, enter. Second row is 1, 1, negative 5, 1, enter, 1, enter, negative 5, enter. And the third row is 0, 1, negative 3, 0, enter, 1, enter, negative 3, enter. So I hope I put that in correctly. I always like to check. Second matrix, A, enter. And we see 1, 1, 1, 1, 1, negative 5, 0, 1, negative 3. Now I've got to put in matrix B. Remember what matrix B was? Matrix B is 360, 0, 0. Let's do that. Second matrix, edit. Over to B, 360, 0, 0, 3 by 1, 3 rows, 1 column. And then we have 360, 0, 0, 360, enter, 0, 0. And then my answer should be A inverse B. So pull up matrix A. The inverse button is here, x to the negative 1. A inverse times matrix B. Second matrix B, enter. And we hope we get x is 120, y is 180, z is 60. Do I? Sure do. 120, 180, 60. $120, $180, $60. So that's a way for me to solve that with matrix inverses. And then if you would do it that way, still need you to do what? Go ahead and put it back in context to put down the words. Again, there were 120 registered Republican voters, 180 registered Democrat voters, and 60 independent voters.